Hi, welcome back. Let's solve this LeetCode problem. We're given a list like this, and we have to merge all the nodes lying in between every pairs of zeros into a single node value, which will have the sum of all the merged nodes. So we have 3 and 1 here. If we merge them into a single node, the sum of these two values will be 4, and the node will have 4. And the next pairs of zeros is here, this zero and this zero here, and we have 4, 5, and 2, and the sum will be 11, and the node will be 11. So we have two nodes, so 4 and 11. So the next example, we have 1 here in between these two zeros, and 3 here in between these two zeros, and 2 and 2 in between these two zeros. The first node will have a value 1, the second node will have a value 3, and the third node will have the sum of these two, so it's going to be 4. Let's jump to this explanation here. Okay, now let's see the explanation. I took this from the first example. We have to merge the values in between zeros. So we have 3 and 1 here, and they're going to merge into a single node like this, 4, and the value 4 comes from their sum, and we're going to have this 3 values. The value will be 11 with a node, and this is going to be a linked list, and we're going to ignore the values 0 nodes itself, because this 0 will be ignored, this will be ignored, and this will be ignored, and we're not going to have them in the result. So what we do actually is here kind of simulation, but how do we actually build this linked list? We could do this in linear time on the way. Let me back up and create a result node here. This will essentially be the result, but initially it does not hold any value, and it does not have to. So we have, and what we do, we're gonna start here. We're gonna have a sum that will hold the running sum. So we have a value of 3. We don't start here because this value, this node has a value of 0. So I'm going to start here, and this value has 3. So we add here to the sum 3, and then we move the head to the next node. So this is 1, and we add it to the sum, and we move again to the next node. This is 0. So now at this point, since this is 0, we know that we have to create a new node with the value sum. The sum is 4, and that now we create a new node 4. Now what we need to do is to append this new node to the end of the existing list. So, but for that we need to know the end of the existing list. So we create an end node that will always point at the last node of the existing list. And currently, initially, it will be pointing at the result. And now we have 4. We created a new node, and the next pointer of end node will point to this new node. And now our existing list looks like this. Now end has to be here, so pointing at 4. Now we move the head to the next node, and by the way, we have to set the sum to 0 as well, and then we move to the head to the next node. Now it's pointing at this node with value 4. We add 4, and we move to the next one. There we have 5, and then we move to the next one. We have 2 here, and then we move to the next one. Now we have 0. So now we know that we have to create a new node. We're creating a node with the value 11, the sum of these values, and now the the next pointer of n will point at this new node, and the end will become the new node itself. And by the way, when we create a new node, its next value automatically is initialized to null, so we don't need to initialize it to null. So we move the head to the next value, the next node. So basically there's no node, the process ends. And now this is our final linked list. But we don't return this because the result is just nonsense. It's a dummy value that we just created to hold the linked list. Actually, this helps us to avoid some if statements in the code. So every iteration, instead of like checking an if, we don't need to do that when we have the result. So actually what we return is the next pointer of the result. So we return actually result.next. So I said dot, but because I'm using the C++, this is going to be an arrow. In fact, if you're using Java or any other language, it will probably a dot.next, something like that. Okay, now let's code the solution. As we said, we're going to create a result node. We're going to call it result new list node. And we'll also have the end. It will initially point at result. We're going to have sum. This will keep the running sum. And we make the head point to the next value. We ignore the first value. And then we start while we reach the end of the list. What we're going to do, as long as the value of the current node is not 0, keep adding the value to the sum. And don't forget to move to the next node. And after we reach the end of this while loop, we either reach the end of the list or we reached a node with 0. So what we do, we actually create a new node. So let's call it node, new list node with the sum. And we'll make the end, the next pointer of end, point at this node. And end itself will point to this node. And we set the sum to 0. And we'll move to the next node. And after the end of the while loop, we're going to return result next. Let's run. Okay, I've got a typo here. Okay, let's submit the code. Yeah, you can see that it works, and we also have the here analyze complexity. It's going to take, okay, it's ON.